Hi, Aaron. Thanks for joining this podcast. I think ever since this LLM concept has started, ever since ChatGPT became popular, I think we soon realized that there is a gap, right? It may not, the way in which the LLMs are created, the way in which it can be deployed into the enterprises, it may not be good enough because it does not take into consideration the enterprise knowledge. It doesn't take into consideration the latest and greatest of knowledge. And that's when RAG also became quite popular, even though it was there for quite some time, right? As I learned from you. I think that's why I started initiating this podcast. So let's start with a quick introduction of you as to like who you are and what is the role you play. Go for it.
Sure. Thanks, Divagar. It's great to be here and thanks for having me. I am Anil, so and I work for Neo4j. In my day job, I own the technical side of partnerships across APAC. And my interest in graph, especially with Neo4j, has been a long journey. So I was first exposed to Panama Papers when the leak happened almost a decade ago. And then I was fascinated how a group of journalists could nail down multiple degrees of connections say between politicians and then shell companies. Then during one of my previous jobs, I was involved in like designing data intensive systems. And that is when I read Martin Klipman's amazing book, Designing Data Intensive Systems. So in my opinion, anyone dealing with data should read that book. So it gave me plenty of good ideas about how to pick the right database for your systems. And then I started applying these ideas and could see that clearly graphs are best suited for various connected data use cases. So this is how I kickstarted. It all kickstarted my love for graphs and Neo4j in particular, but with passion to be in front of customers and then listening to them landed my current role. So having said that, that is where I'm today. But of late, RAG is getting more popular. Like you said, retrieval is actually it's a problem that has been existing for quite some time, and it got more focus only recently after when the LLM became into mainstream. So yeah, I'll be very happy to talk to you about it, and then very happy to discuss about it.
Thanks a lot, Aaron. In your own words, like how would you describe that?
Okay, so if I have to,
Base.
okay, sure. So first, let's imagine a really smart AI that could write essays and answer questions like ChatGPT. So this AI has been trained on huge amount of internet data up to a certain date. Now, what if you want to have this AI to answer your own questions about, say, your company's latest product, which wasn't around when the data was when the AI was trained. So that is where RAG comes into picture. So RAG actually stands for Retrieval Augmented Generation. It's like giving AI a custom textbook to refer to before answering a question. So here is, if you deep dive into it, here is how it works. Even though the jargon itself is very complex to hear and then hear, but the concept is very simple. You ask a question, the system looks through your custom database, that is the textbook, to find relevant information. And then it gives this information to the AI as context. And then finally, the AI uses both its training and then this new context to answer your question. So this approach has two big benefits if you see. First, the AI can give up-to-date answers without needing it to be retrained, without needing any fine-tuning or any retraining with the latest data. And that brings down a big amount of cost for you. And then the other advantage is it reduces hallucination or confabulation, like people call it. So there are instances where an AI can make up information because it doesn't have the right context. So you can avoid that using RAG. For example, if you ask what feature does our new smartphone or new product have, a regular AI might give you an outdated or a very incorrect information because it doesn't have that information. But with RAG, it would first look up in the latest product specs of your database and then it gives you an accurate answer.
So let's if we have to backstep a little bit and think about like when this concept originated, like, and when it, of course, the hype happened along with the ChatGPT and the LLMs. But how has the journey been with RAG? Like, will you be able to touch upon a little bit on that?
Oh yeah, sure. I think it's a great question because people think that there are only a few ways to do RAG nowadays, but it's a very relevant question I can give you a short history about it. So to understand RAG or even graph RAG, let's first look into multiple different ways of storing and then retrieving information. So one of the ways is text index. Like it's also called a sparse vector retrieval. So this is like using a book's index to retrieve the relevant information. It is good for exact matches, but like keywords, but it struggles with similar concepts. For example, if you ask where does Divakar live, it might not find where Divakar resides in Bangalore, because at DB you might have like instead of resides you might have Divakar lives in Bangalore. So it's not similar, but it matches keyword. But this is like a proven way to it's like a baseline mechanism to do RAG to start with. Then you have dense vector retrieval. This is like grouping similar concepts together. So your database does that for you. It is better at finding related information but it still misses some important connections. Going back to a previous example, if I ask where does Divakar live, it can find Divakar resides in Bangalore, but it has no understanding of connected information for Bangalore, where this state is and which country this state is located. So it cannot find the connected information there, but it can still identify similar information.
Okay.
And recently you have retrieval mechanisms like graph-based retrieval or graph RAG. This is like having a map of interconnected information. This method excels at finding and using connections between different pieces of data. If you ask the same question, it can ask based on the connections Bangalore has with Karnataka, and then it is located within India. And it can also give you additional information like where does Divakar's friend live in. So do we have any Divakar's friend living within Bangalore? So this is these are the various retrieval mechanisms that you can use with RAG. And it depends on the use cases, how comprehensive and how contextually relevant information that you want your system to answer.
That's a very good segue, right? Like I was about to ask, like, since we have different techniques for RAG, obviously, like we should not be thinking that, graph-based RAG is the best form for any kind of application.
Yeah.
So at a high level, like if I'm starting a new project, like how do I decide what is the...
Oh, yeah. So in short, whenever you need more recall, when you compare with precision,
Right.
And we deal with situations where you don't need a multi-hop query, you go for a sparse or a dense vector retrieval. That is good to start with. It gives you a baseline way to build a RAG. So especially with sparse and then dense vector retrievals, you can get good recall. Go for graph RAG when you want to get more precision and accuracy. Typically, when you are in an investment banker, you want to look into a 360-degree view of your investments, the companies you are investing with, taking care into what kind of businesses they deal with and what kind of exposure they have in various industries. So this is where you have more contextual information. You need more contextual information, and also you want to go beyond precision and accuracy. So that is where you need to go for a graph RAG. So also you can consider, let's take...
Sorry to interrupt you. For this podcast is a little bit for novices also, for people who do not understand the confusion metrics as to the precision, recall, etc. Yeah. Maybe you can go scenario based. This is
cool. So let's take a customer service scenario.
Right.
Let's say you run an e-commerce company, and then you have a customer service scenario. If you are a regular RAG user, you'll be asking a question like if you are building a dense or sparse based retrieval system, you'll be asking a question like, I'm having issues with my sales order. Let's say 1, 2, 3, 4, 5.
Right.
And then what the system does is it goes to the database and it retrieves basic order details based on the sales order number, like the date the sales order was made, and then the items that the sales order has.
Right.
And then it gives you all this information. Then it ask you a question. Okay, based on the retrieved information from the database, I see that you made an order on September 1st, and then for laptop and headphones. And then what are all the specific issues that you're experiencing? So this is like a basic retrieval mechanism that you have with regular RAG. It's good for recall.
Okay.
But when you go for graph RAG, what happens is that when you go for a next level, you might be having I'm having this issue with my order, sales order number. And then what the system does is that it goes to because it has all the connected information there, it retrieves along with the sales order information. It also finds that okay, you notice this is your third order with us, and you have been a customer since 2020 or something, and then this has been a known issue with our laptop model because this is what we see with other customers as well, and it roughly affects X percent of users. and it gives you a lot of contextual information. And so if you want to build a system like this, then that is where you need more precision, because here you are dealing with a limited set of connected information, and this is where you go for a precision. But with recall, you want more retrieved documents, and then you do a RAG on top of recall based system. So either of them are fit for certain purposes. It's not. I'm not saying that one purpose is better than the other one.
So, since we have multiple options, I think especially in this new gen IT world, like we always have this like huge set of overwhelming set of tools which we constantly evaluate and try to incorporate within our system, right? Like if we have to go about evaluating these RAG for our enterprise system, how do you approach the evaluation phase alone, saying that, okay, this is the right mechanism? Any thought on that? Are there any tools, techniques?
So yes, yeah, I think this is a very I like this question, because a lot of people come into RAG, they build a quick demo and then they say, okay, let's do RAG. But in reality, it takes a lot of time and effort to properly build a RAG system. So what we have seen is that we always ask people to start very simple. So focus on you start with the very basic, very baseline chatbot or any GenAI based RAG based system, and then you analyze your queries. So look at the type of questions that the users are asking, and then you say, okay, whether it's a factual question or it is like a complex multi-hop question. Then you try to improvise the system. And when you want to evaluate your performance, use metrics like relevance, accuracy, and then the response time. So you can typically, based on the kind of questions users create, if you don't have that data upfront, you can generate some synthetic data. You can ask a RAG system and then build some synthetic question for you, and then evaluate the answer that the system generates. Compare that synthetic question and answer with the one generated by the system. Then you get precision and recall. So this is where you start with the metrics, and then once your users start using it, now you get all the analytics from the users, right? What kind of questions they want, and this is where you would do topic modeling. For example, what kind of questions that users ask? Are they like time frame based question? Then you can tweak your system accordingly. Are they like pure multi-hop question? Then you can make more entities, change your data model, and then do more hop related templated queries. And then this is where you start to identify the gaps. Where exactly my system is falling apart, and where am I missing the user's interest? So once you capture this over a period of time, and then you apply the fixes every now and then it gives you a very good understanding of your system, and then you can go for like more complex implementations. Like you can bring in more data, start connecting your systems, whatever data you have already, and then you can also bring in like multiple data sources. It can be from SQL databases, it can be from graph databases, it can be from NoSQL databases, and then basically start experimenting with all these things, with all the evals that you have, and that will give you a very good idea about it.
I think I mean, if I have to double click this topic a little bit more, it's easy to say that, compare and see like, how the results have been faring, right?
Yes, I can hear you.
So maybe it's some internet connectivity issue. Where I was going was like, it is easy to say that, we need to do the evaluation, but if I have to draw some parallels with the typical testing that we do, right? There was a direct relationship between the output and what is the expected output, right? You do a testing, you get an output, and you have an expected output. Like 1 + 1 is equal to 2, like 2 is equal to 2, like that the test is passed, something like that. But in LLM based model, it is a bit complicated, at least for me, in terms of understanding what is the output that is generated and how does it compare with the output I'm expecting, because it's all text and it's all verbose, right? So in that scenario, especially for the different discussions that might happen, right? The way the questions are being proposed, the way the questions are being asked, and the way the follow-up questions are asked, etc. Like the comparison itself is becoming tricky, right? Don't you think?
Oh yes, it is, because there are a lot of moving parts. Because LLM is like, end of the day, it's like they are all probabilistic systems, and you cannot expect too much of determinism in that. Yes, And that is the reason, like, you have to minimize the number of indeterministic features that you have. There is no way to seed an LLM and then you can simply seed the number and then you can ask the LLM to give you constant results. So that is not going to happen because of the probability that you are dealing with.
Right.
So what you can do is that you can minimize the number of moving parts. For example, there is a concept like what you call as semantic layers, where you have templated queries with your system, and then using LLM's tool calling or function calling capability, you can bring in some sort of determinism there.
Okay.
So yeah, once you execute these queries in a database, it's going to always give you the same results, same set of results.
Got
From a database. So that way you can minimize it. But end of the day, like you said, if the your text generation itself is free flow, then you don't have much option to you have to live by that. The other way is you also test. You usually test for the facts that are being generated, not for the eventual result that the LLM produces. So that way you can bring in a lot more determinism in your evaluation as well.
Another question that comes to my mind, in fact, like the other day I was trying out my own iPhone Siri and I was having a chat with it. It felt like it was having a chat with me, like, but at some point in time, like it lost the context. Even in fact, with the second question itself, it totally forgot what my first question was. I don't know if it's the right use case for Siri, but it made me think about as to how the conversation goes. Like, what is the amount of context that it can retain? Because when we are having a free flow chat kind of an experience with the end user would assume that the LLMs are like capable of handling the context switching, etc., but it may not in reality, right? So, any thought on how this kind of use cases can be handled?
Oh yes. So yeah, when you talk about context, it's always about like all the connections that you are talking about. So as long as you have a retrieval mechanism that can take care of these connections, then it is very easier to maintain the context same. Like going back to the previous example of having a customer requesting a sales order. Since I have the context like this for that particular customer, that this is the customer ordered this product, and that is from the customer point of view, and similarly from the product point of view, that this product has a lot of issues previously reported by other customers. Say, let's say. So when you have all this context, then your LLM will be able to have, actually answer you much more relevantly. It will be more faithful to your question, and then it will be able to follow up the question and then answer it in the way that you want. So this is where the need to connect multiple siloed data to one is really, really useful for you. That is actually needed for you.
And I'm also seeing that controlled flow that is being implemented at the application layer also, right? For example, like in airlines and airlines kind of a chatbot or in a banking kind of a chatbot, they seem to be controlling the flow of like how that way, like they're giving the experience of the chat while keeping the higher level context or the transaction as a context for the end user. Like, for example, if it is a banking application, maybe the end user is trying to understand the timings of the branch operations. And maybe like another context could be like, whether that person is actually trying to work on account opening formalities, etc. By having separate controlled flow for these applications, we are able to segregate the context also is what I felt. So there is some amount of work that is needed on application end. Any thoughts?
Oh yes, of course. So what do you see? Yeah, you are right. So everything is like a process flow, especially these kind of scenarios, which is like there is one process and then that process might have like 2 or 3 child processes, like our pathways, you can say, which is nothing but how I see is that these are all like chat for traditionally chatbots like this have been using graphs because process flow is nothing but a graph. If you think in that sense, and now with Genie, along with when you talk about user context, which is like another set of connected data, you actually can very easily connect these two together and then guide the LLM towards this is going to be my next pathway. This is the next step that you have to take the user, and this is what the user's context is.
Okay.
So this way you can merge both these worlds together to make the answer more relevant for the user. Yeah.
I think the next one I have is a little bit controversial question. I know that you're associated with the company, but I also want to understand, like, now that the concept of RAG itself seems to be like a bit commoditized. Like I'm seeing every other database vendor, like there are multiple players in the field who are providing this functionality of a RAG database. So how does one approach the evaluation, or what are the typical ways in which a customer evaluate these competing products?
Yeah, that's a great question. So before that, we need to understand the various types of graph databases that are available today. So I would usually put them into two buckets. So that helps you to actually evaluate which one is suited for you. So one is a set of native and then native graph databases. Another one is non-native graph databases. So when I say native graph databases, they are the ones that store the nodes, the circles that you see in a graph, and then the edges are the relationships that connect these two circles together. So they store the nodes and edges as is in the storage layer. So that means they don't convert this representation into, say, tables and columns, or even into key value pairs.
Okay.
So that I would put these kind of sets of databases as native databases, and they are great because they tend to use index-free adjacency. They don't rely indexes too much. So it's easier for them to search through, say, billions of data sets that you have or nodes that you have. They could traverse within a fraction of seconds. And they can do a lot of multi-hops. And so whenever you care about performance, usually people go for native graph databases.
Okay.
And on the other end, you have non-native graph databases, or more you call like multimodal databases. So they are built. These are the new set of databases that have graph APIs on top of traditional database architectures, like relational databases or NoSQL databases. So nowadays you see a lot of cloud providers add these kind of capabilities to the databases. That basically they will have a relational database, but they have a graph layer, and that means I can use the graph API to actually talk to this databases and then get my data. But end of the day, it's still a relational database. They will not be highly performant. So you have to keep that one in mind. They are very easier to get you started. For example, if you're running a relational database already, you can actually start with that. But once your use case once you understand that you need to connect more data, then you have to, that is where you need a lot of multi-hop capabilities. So that is where you move towards a native solution. Yeah, so this is what I've been seeing. This is the trend I see with my customers as well. And the other thing to consider is about schema flexibility. So graph databases, because it tends to connect a lot more data, whenever you are evaluating some database, you have to be really mindful of schema flexibility.
Okay.
So today I might have, say, all my customer related information. But tomorrow I might need to integrate supply related information into this customer database. So that is where I will think of reorienting my schema, redesigning my schema.
Okay.
So in these cases, a graph database should be very schema flexible to adapt and take this new information. So without needing any explicit code changes. So this is another important criteria to consider for if you're evaluating any kind of graph databases. Yeah.
And in terms of like the portability, like does all these products support native portability of like the RAG database from one customer to another customer, or one vendor to another vendor? Is it a standard format that?
Yeah, in terms of portability, yeah, there are two kinds of portability that we're talking about. One is on the code side. So on the code side, previously it used to be Gremlins. SQL is the default way to connect with any relational database. Similarly, you have a graph query language standard. That is the next standard after SQL after like 40 years. So this is the new standard that is happening today. And and the query languages that implement GQL are like Cypher, OpenCypher. OpenCypher is quite popular in many of these graph databases. It's a very standard way to connect. So that way you have a portability. Any graph query language that adheres to GQL standards will be able to make some easy code migration related changes there. But when you talk about data migration itself, you have there is no direct way to say dump from one graph database to another.
Okay.
You still have to rely on intermediary formats like CSV and.
Got it. You would export it and then import it back. Okay, traditional ways.
Yes. Yes.
You have been in this world for quite some time, right? And especially with the Graph DB, like it has started having traction, at least in my world, like after Microsoft published one of the recent papers, right? Even though a graph database was existing for quite some time. What are some of the popular implementations of GraphDB which some of our viewers can actually go and check out? Something that comes top of your mind, like, as a where they have implemented it, right? From the way RAG is implemented, even from the application layer, like, how controls are kept in place so that the context is retained and channelized, etc. Anything that pops in your mind?
Yes, sure. So actually, GraphRag, yeah, it was popularized with the Microsoft paper, but the usage of GraphDB was prior to that. So like when Panama Papers was leaked like 10 years back, it was like a very big thing that was a very big news around the world.
Right.
About GraphDB, these new kind of databases. Yeah, like you said, with GraphRag especially, I see a lot of implementations on companies like Klarna. So Klarna it's a big neobank in the Europe. So they have been using a lot of building regular systems on off late recently, and GraphRag is one of them. So they have been doing a lot of wide variety of transformations using GenAI, and it looks like it shows that they seem to get a good ROI out of it. So that is one publicly available use case that I could quote. Similarly, you have other companies and customers that we are working closely in the region within APAC and then outside as well. So where they see pretty good ROI. So I see a couple of days back, I saw like a recent ROI study from Google. So that said, like 5 to 6 months, a lot of enterprises that implement RAG are seeing very good ROI. That means they are able to see some value out of it. Out of their investments. So yeah, you'll see more use cases like this recently. Like people have been thinking a lot about how to improve the precision and accuracy, how to make evals better, and so you will see a lot of these success stories in the upcoming days. Yeah.
I think during our coffee time chat, like we talked about like what is next in RAG. I think that was very interesting for me. Like, do you want to share that thought for our viewers as well?
Oh yes, definitely. Last week I heard about Graph Reader. So it is another interesting paper recently. So especially on the GraphRag part. So because people thought that once you have a proper graph system in place, you need to have like really well defined nodes and edges. But the Graph Reader paper, what they did was like they broke down a huge chunk of text, like how you break down typically in a vector database, and then you can do GraphRag even with those chunks without the need for doing highly complicated entity extraction process. So that means you can start with GraphRag very soon. Like you can once you chunk your data and then convert them into vectors, yeah, you can very easily start with doing a GraphRag. So they see like promising accuracy using that. So unless you need like complicated multi-hop questions, for most of the use cases, this can be a very good approach to do GraphRag. So that is on the GraphRag side of things. And I'm also interested in like neuro-symbolic AI. I'm not sure how close to basically what it means is that you make a foundation model to think in terms of connected entities, in terms of graphs. And then that way you can, people are trying to see whether it can make better, it can have better reasoning capabilities. So one way is that the O1 release from OpenAI recently has pretty good reasoning capabilities, they say. But end of the day, it is still, they are all like, most of these models are very auto-regressive. So that means it depends on the way they are trained with the eventual output. Because you trained a huge amount of data, the model somehow adjusts their parameters and weights to answer in a certain manner. So we are still missing on the reasoning part. So I think maybe the neuro-symbolic AI might be a good option for that. But who knows? Yeah, that can be a new approach to it from someone else. Yeah.
Yeah, hopefully, I mean, like, a lot of topics are changing quite rapidly. Hopefully, this topic is not going to expire very fast. Fingers crossed. And especially on the GraphDB, that's something very interesting for me, Errol, like because of the way, especially because of the relationships that is baked into the system, right? Like, and how the RAG query can dynamically use this relation to create contextual information for querying, right? So when we are building this kind of a GraphDB, like, do we need to do some paperwork? For example, traditionally we have, when we are doing the relational database management system, now like there's a lot of design work that happens behind the scenes, right? As to like how this DB should be created or the relationships, the entities, etc., etc. So what is the parallel in a graph?
Yes, so that's a good question. So you do have a similar schema related data modeling exercise that people typically do with graphs. But it doesn't have, you don't have to know everything.
Okay.
Like it's similar to how you design a SQL database. You go with a whiteboard model. You sit with it. You come up with a whiteboard modeling basically, and then you connect the entities and then see how I should join the tables. So the good thing with graph is that you can convert that whiteboard model as your schema. You don't need to actually convert it into a manner that is understandable by the SQL system. Like you don't need to have like a table. You don't need to think in that manner. You can convert a whiteboard model into a graph. So having said that, when it comes with a graph RAG, you can either go with those well-defined schema. If you're investing like not just on GenAI use case but other use cases, that is the way to go. I would suggest. But if you don't want to do like, if you have like several millions of PDF documents which you want to do graph RAG, and you don't need domain specific model there, you can simply chunk the documents, break them into small chunks, convert them into vectors, and then capture how these chunks are related, and then put it in the database. So the graph reader approach that I was talking about does exactly the same thing. So basically, it takes key elements from these chunks, and then once you ask a question, it also tries to, because everything is connected, it tries to relate to a key element that you're talking about across multiple documents. So that way you can see the related information in your eventual results. So which is like a quickest way to get started, and then fastest way to get the information that you are looking for.
Okay, nice. I think like when we met, like you shared a lot of resources on like how to get started. Do you want to tell to your viewers, to those who are the beginners, like how does one start?
Yeah. So if you are new to RAG system altogether, the best way is you can go to LangChain or Llama Index. These are popular orchestration frameworks. You can go there. They have plenty of useful documents, and in fact, LangChain came up with a free online course recently on LangGraph. So that's a very good way to start if you're new to RAG. Then if you want to go like a little bit, and if you want to learn more about graphs and graph RAGs, the Neo4j has Graph Academy, which is like 100% free. So anyone can go there, learn about the basics of graphs. Usually these videos are like 1 hour, 2 hour kind of videos. Can very easily learn it. I started my graph learning like that. So and it's also easier to get certified as well. So if you want to get freely certified, these are all the places I would go. You call it as graphacademy.neo4j.com. So that is where you go there. And similarly for LangChain and Llama Index, they are quite popular frameworks. And you can very easily start with playing, come up with a toy demo, and then see how various RAG systems perform for your very simple query. So you can always start with very simple PDF documents. It can be your personal financial statements, your bank statements. You can think how you can convert this financial statements from your bank into a quick chatbot. Immediately play around with these tools very easily, and together with the recent AI-driven IDEs like Cursor or Replit, it's very easier to you cannot. There is no excuse for you not to start with these projects. Like it's simply if you just know English, with a few prompts you can build a full-fledged RAG solution.
Yeah.
And that way you can deploy it in production. That is another important thing. So you can come up with production grade application just by knowing English.
Right.
It's a very good way to start.
Yeah, I was going through some of these resources that you mentioned, like when we met, and I especially like the visualization part of it, right? Like you're able to see the entities, the relationship, how it connects with each other, etc. That was very good for me, like just from technical perspective as well, and like even with the Cypher queries, like you're able to see like the data it is getting retrieved. That kind of like validates how this DB is performing, like, and whether we are retrieving the right amount of context for our application, etc. That those are very useful. I think I'm done with all my questions. Like, thanks for taking time and attending this podcast, Cyril. Looking forward for another exciting podcast from you. Yeah, thank you.
Thank you, Divakar. So it has been my pleasure, and I hope this discussion helps our listeners as well to see the potential of RAG systems in making a more powerful AI. So yeah, always remember the key is to start simple and then understand your specific needs. Again, thanks for your time, and then thanks for having me here.
Thanks.